Hey Calculus, in this video we are going to learn how to generate the derivatives of the other four trig functions. We already know that the derivative of the sine is the cosine of x, and we know that the derivative of the cosine of x is negative sine of x. So we're going to learn the other four derivatives: tangent, cotangent, secant, and cosecant. And we're going to learn how to generate them, so in case you forget them, you can figure out how to find them on your own. But once we generate them, then you'll know them, and it'll be like derivative flashcards. You just have to know them. So, to find the derivative of the tangent, written as this, there's no rule that will work. The power rule won't work, the quotient rule won't work, the product rule won't work, and the tangent rule will not work. But we can rewrite this using a quotient. Alright, so the first thing we're going to do is we're going to rewrite this. We know that tangent from way back in the pre-calc days is the same as the sine of x over the cosine of x. Using the quotient identity, now one of our rules will work. We can use the quotient rule now because it is a quotient. So let's set up the quotient rule. We start with low. Low as is the cosine of x. The derivative of the high, the derivative of the numerator, is also cosine of x. So that's our quotient rule, low d high. Now it's minus the high function as is, so the sine of x. And then we come back with d low. The derivative of the cosine is negative sine of x. So there is high as is times d low. All right, and of course the denominator is low, the denominator, and you square it. Okay, now let's simplify each term in the numerator. We get cosine squared to the left of the minus sign. On the right we have a negative and a negative, so this becomes positive. Sine squared of x all over the cosine squared of x. Okay, now we have to go back to pre-calc, and we have to remember the Pythagorean identities. Remember, the cosine squared plus the sine squared is equal to 1. So that now becomes 1 in the numerator, 1 over the cosine squared. All right, and now we can simplify that again. That is equal to, the reciprocal of the cosine is the secant, so 1 over cosine squared of x is equal to the secant squared of x. So that is the derivative of the tangent. You will do the same thing to find the derivative of the cotangent. You will rewrite it using a quotient, and we know that the cotangent is the same as cosine of x over the sine of x, and then you would use the quotient rule. So I want you to turn off the video right now, and I want you to try it on your own. Set up the quotient rule and then simplify and see if you can find the derivative of the cotangent. Go. Okay, let's go through it. All right, the quotient rule. We start with low, so the sine of x, that is low, times the derivative of the high. The derivative of the cosine, of course, is negative sine of x. So that is d high, and then it is minus high, so we have the cosine of x. So that is high, and now we need the low. The derivative of the sine here is cosine of x. So that is d low, squeeze it in. All over low squared. The denominator is sine of x, and we square it. All right, now we simplify. On top, a sine times a negative sine, of course, gives us negative sine squared of x. On the right you have a negative, and then you have a cosine and a cosine, so that gives us negative cosine squared of x all over sine squared of x. Now we go to the Pythagorean identities. If they're both negative, negative sine squared of x minus cosine squared of x, that's going to give you a negative 1. Alright, so if we simplify that, we get negative 1 over sine squared of x. And we know using the quotient identities that the reciprocal of the sine, 1 over sine of x, is equal to cosecant of x. So that's going to simplify to negative cosecant squared of x. And that is the derivative of the cotangent. So the derivative of the tangent is secant squared. Memorize it. The derivative of the cotangent is negative cosecant squared of x. Okay, number 3 is going to be very similar. We have no derivative rule that will work for plain old secant of x, so we rewrite this using the quotient identities from pre-calculus. All right, the reciprocal of the secant is the cosine. So the secant is equal to 1 over the cosine of x. All right, now we do the quotient rule. Our low function is cosine, and our high function is 1. So we start with low, cosine of x. That is low. D high, the derivative of the high function, the derivative of 1 is just 0. Nice, because that's going to wipe out half of our numerator. Then we come back with minus high as is, so that is 1. And then we need d low. The derivative of the cosine is negative sine of x. So there's our numerator, low d high minus high d low. And on the bottom, we just need low squared, cosine of x squared. All right, we simplify each term in the numerator. This term is gone. It's times 0. Over here, we have a negative and a negative, so that's positive. And 1 times the sine is just the sine of x. On the bottom, we have cosine squared of x. Okay, now I'm going to rewrite the bottom. All right, rewrite the denominator. Sine of x is going to stay, but I'm going to pull those apart. Cosine squared of x is equal to the cosine of x times the cosine of x. All right? Okay, now I'm going to rewrite as 2 separate fractions. And I'll show you why in just a minute. All right? This numerator, I'm going to rewrite it like this. It's going to be 1 times the sine of x. All right, so the sine of x is the same as 1 times the sine of x, and I'm going to put these cosines in the denominator. So 1 over the cosine of x times sine of x over the cosine of x. Okay, this one right here, 1 over the cosine, that is the secant of x. And sine over cosine is equal to the tangent of x. So there is our derivative of the secant of x, right here. All right, the derivative of the secant of x consists of 2 functions multiplied together. The derivative of the secant of x is the secant of x times the tangent of x. Now, I always put the secant of x first. Simply that helps me remember that the derivative of the secant of x starts with the secant of x. Secant of x times the tangent of x. Okay, let's do the last one. We're going to do it exactly the same. We are going to rewrite the cosecant of x using a quotient, so that's the same as 1 over the sine of x. Those are reciprocals of each other, and then we are going to use the quotient rule. I would encourage you to turn off the video and try it on your own and see if you can get it. Okay, the quotient rule starts always with low. You have to start with low. So low as is, of course, is the sine of x. The derivative of the high function, the derivative of 1 is just 0. Then it is minus, then we come back with high as is, times d low. And the derivative of the sine is cosine of x. All right, looking pretty similar. On the bottom, it is the denominator, sine of x, but we square it, low squared. All right, let's simplify each term in the numerator. This term goes away. Sine of x times 0 is 0. Here we have negative cosine of x, all over the sine of x squared. Okay, now just like we did earlier, we're going to rewrite as 2 separate fractions. Okay, so I'm going to leave the negative out front, but I'm going to rewrite the numerators as 1 times the cosine of x. On the bottom, I'm going to pull this apart, and I'm going to put one sine of x here and one sine of x here. Okay, now here it is. 1 over the sine, the reciprocal of the sine of x, of course, is cosecant of x. And cosine over sine is cotangent of x. So there is the derivative of the cosecant. The derivative of the cosecant of x starts with itself, and it consists of two functions multiplied together. The derivative is negative cosecant of x times the cotangent of x. Okay, let's write them all down. The derivatives, flashcards, you just need to know them, memorize them. The derivative of the sine of x is cosine of x. The derivative of cosine of x is negative sine of x. The derivative of tangent of x is secant squared of x. The derivative of cosecant of x is negative cosecant of x, cotangent of x. It starts with itself. The derivative of secant of x also starts with itself. It is the secant of x times the tangent of x. And finally, the derivative of the cotangent of x is negative cosecant squared of x. Okay, and the review ones, the derivative of ln x is 1 over x. The derivative of e to the x is e to the x. The derivative of b to the x, an exponential function of any base other than e, you rewrite the function and you multiply it by the natural log of the base. The derivative of 100, the derivative of any number is 0, and of course the derivative of x is the same as 1x to the first, and if you use the power rule, the derivative of x is 1. Okay, please make sure you review the reciprocal identities. Okay, the reciprocal of the sine of x is the cosecant of x. The reciprocal of cosine is 1 over the secant, tangent is 1 over cotangent, cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent. So in the reciprocal world, the sine and the cosecant go together, the cosine and the secant go together, and the tangent and the cotangent go together. All right, and the quotient identities, make sure you know those. The tangent is the same as sine of x over cosine of x. The cotangent of x is equal to cosine of x over sine of x. Now let's use them in some... Okay, example number 1. We have to remember how to figure out what rule to use. We only have one variable. We only see the letter x once, but there's 3 different functions. We have tangent, we have something to the 5th, and we have 7x. I would always rewrite that trig notation. Rewrite it. That exponent, whenever it's written in the middle, it applies to everything immediately to the left and to the right of it. So when I rewrite it, it looks like this. 3 parentheses tangent of 7x all to the 5th. Then that helps you to see what is really the outermost function. So we have 3 functions. We have a double chain, 2 chains. The number of chains is always 1 less than the number of functions. So our outermost function for our first chain is something to the 5th. The inner function is always everything else, tangent of 7x. Remember, you can only have one function as your outer function, so the other 2 have to be here. Now we know this is still a composite function, so our second chain, our outer function is tangent, and our inner function is 7x. Now remember, in a double chain, on the first chain, you only do the first 2 steps. You do the derivative of the outer, and you plug in the inner as is, and then you start over. And on the last chain, you do all 3 steps. All right, so let's get started. First chain, the derivative of something to the 5th is 5 times something to the 4th. All right, that is the derivative of the outer. Now we plug in the inner as is right here. So we have the tangent of 7x. So that is the derivative of the inner function. All right, this is all we're going to do with that first chain. First 2 steps. Now we start over. The derivative of the tangent is secant squared of x. Remember, when you take the derivative of the outer, you need a blank set of parentheses. So you write it as secant squared of something. So that is the derivative of the outer. Now you plug in the inner as is right here, 7x So that is the derivative of the inner, and don't forget on the last chain you need the last step. The derivative of 7x using the power rule is 7. So that is the derivative of the inner, and then this whole thing right here is the second chain. Okay, now to simplify this, you need to put the 5 and the 7 out front. All right, so I'm just going to sneak it in down here. We have 35. All right, and then what's left? Well, we have a tangent of 7x all to the 4th, and we have a secant squared of 7x. All right, there you have it. Okay, secant of 7x. Well, there's only two functions, 1, 2, and there's only one variable, so that is a chain rule. My outer function is secant, and my inner function is 7x. All right, now here is a little bit different. The derivative of the secant is secant x tangent x. It's two functions. And you can never put in an x when you take the derivative of the outer. So we do the secant of something and the tangent of something. All right, that is the derivative of the outer. Remember, when you take the derivative of the outer, you cannot put in an x. It's only blank set of parentheses. So when your derivative of the outer consists of two functions, guess what? You have to put that inner as is in both places. All right, so we have to put it here, and we have to put it here. All right, so the inner as is, it goes in both places. How crazy is that? All right, finally, the derivative of the inner is 7. So that is the derivative of the inner. So when you rewrite that, simplify it, of course, the 7 comes out front. 7 secant of 7x times the tangent of 7x. All right, thanks, calculus.